The liquid solutions are of two types: ideal solutions and non-ideal solutions. Let us first take ideal solutions. Ideal solutions, as we have been knowing ideal gases, we can correlate that particular term with this term. So ideal solutions are the solutions which follows Raoult's law under the almost all conditions of the temperature and pressure. So the solutions which follows Raoult's law are called ideal solutions. So the most important thing, they follow Raoult's law. Now the basic of following the Raoult's law is that the interparticle forces between the solute and the solvent in these solutions are exactly similar to what they have been having in their individual cases. It means what? Whatever the forces were existing in the original solute between solute molecules and solvent molecules, the same type of forces with same magnitude exist when they are mixed together. So what we can write in short is that whatever the type of forces are there between intermolecular forces or interparticle forces between solute and solvent AB, the same type were present in the original between solute, solvent and solvent. So what we can write it, what does this mean is that the intermolecular forces or interparticle forces between solute and solvent are exactly of the same magnitude and exactly of the same type as they used to be between the original solvent and solute molecules. When the forces are similar, what we find is they behave in a very similar way as they have been behaving when they were present alone. The presence of one another doesn't affect them. So they show the same behavior. And that is why what we find is the graphs vary linearly. The graphs vary linearly because they are behaving as such as they have been in their pure state. Now in such cases, that is why what we find is no net change in the volume of the solution takes place. So this is always is equal to 0. Neither the volume gets increased or decreases. Similarly, the enthalpy of the solution, the amount of energy released or absorbed when the solution is formed, is also 0, because whatever the forces, earlier forces between solvent and the solute are broken, and whatever the amount of energy was required to break all those forces, the same amount of energy is released when the new types of forces between solute and solvent are formed. So the same type of energy, the same amount of energy is released. So the net enthalpy of the solution is 0. So these type of solutions are called ideal solutions. See, whenever we never know, whenever we are mixing two liquids, how they will behave. We never know, because we think they will be behaving like ideal solution. The forces between them will be exactly same as they have been existing in their individual cases. But sometimes what happens is the forces gets changed. They either become stronger or weaker. So whenever all these conditions are not followed, what we find that those solutions, liquid solutions, become what? Non-ideal. Before moving into the non-ideal solutions, let us first see some examples of the ideal solutions. The examples can be the one in which when mixed will have almost the same type of interparticle forces, like we can have when N-hexane and N-heptane are mixed. We get ideal solution. When benzene and toluene are fixed, we get ideal solution. When chloroethane and bromoethane are mixed, we get ideal solutions. So all these are the examples of ideal solutions. And remember, the graph of the ideal solutions are always the same px diagram which we have done in the liquid solutions. Now let us move to the non-ideal solutions.